We have an LED and we have our power supply, and it's 13.6 volts on it, and we want to connect this LED to power. If we connect it straight to a power supply, let's see what happens to it. We just get a flash and it goes off. It dies out almost immediately. Unlike regular bulbs, LEDs don't limit current by themselves. Too much current leads to overheating and burnout. Okay, so we have to introduce resistors to the circuits to limit currents and ensure the LEDs receive just the right amount of current that they need. So this is a new one. So for us to be able to limit the amount of current this LED needs, we would have to put a resistor in series with this LED, and we'll be applying Ohm's law, which is V equal to IR. Alright, so we know in series voltage divides across the loads. Okay, so we're expecting the voltage to divide across the resistor and across this LED. Now this is a 3 volts LED. We're expecting to have 3 volts across its ends. Okay, so since we know the voltage drop we're going to have across this resistor, alright, we can subtract that voltage drop from the overall voltage from the power supply to get the voltage that will be across the resistor. Okay, so we have 13 volts, approximately 13 volts here on our voltage supply, and we're going to have 3 volts on this LED because it's a 3 volts LED. If we subtract 3 volts from 13, we're going to have 10 volts. So we're expected to have approximately 10 volts across our resistor. So for this LED, from the manufacturer, I found that the maximum current allowed to flow through this LED is 30 milliamps. So I'm going to be passing only 20 milliamps through it. Okay, so if we take the current we want to go through this LED to be 20 milliamps, because the resistor is in series with it, we would have 20 milliamps through the resistor too. So if we have the voltage across the resistor to be approximately 10.7 volts and the current through it to be 20 milliamps, then we can find the value of our resistor by dividing 10.7 by 20 milliamps. And if we do that, we'll be having 535 ohms. But I don't have 535 ohms resistors. I rather have 510 ohms resistors, and I have 630 ohms resistors. These are the closest values I have. Okay, so 510 ohm resistor will be smaller than 535. If we use this, we are going to be passing more current than 20 milliamps. So I have to use a higher resistance. And the next I have in value is 680 ohms. So I have now find out what current 680 ohms will allow go through my LED. And we'll do that by dividing 10.7 ohms by the value of the resistor I have. So we'll get the amount of current that will be flowing through the resistor when this resistor is placed. Now the same current flowing through the resistor will be the same current that flows into the LED because they are in series. So if we do that, we're going to have approximately 15 milliamps. So I bring in my breadboard, my LED, and my 680 ohm resistors, and a couple of jumpers. Okay, so connecting this, I have my LED lighting up. Now let's confirm the amount of current we have flowing through this. I bring in my multimeter. So we now update our voltage value because now we have 13.9 volts on our voltage supply. So we update that and we get our current going through the resistor and through the LED at approximately 16 milliamps. So let's find out if that's exactly what we have. So we have to connect our ammeter in series, okay, to get the exact value that would be going through this LED. After opening up the circuit and connecting the ammeter, okay, so we can see we have approximately 16 milliamps going into or going through the LED. Okay, that's what voltage we have across the LED. So if we bring back our multimeter and we read the voltage across our LED, would have that to be roughly 2.9 volts. Okay, so that's approximately 3 volts. It's a 3 volts LED, so we would have 3 volts across it. Okay, as soon as we have 3 volts across it, the LED lights up and draws as much current as it can draw. Alright, so that's why we need a resistor to limit the current flow, otherwise it will pull as much current as it can. Here we have our resistor to be quite hot, okay, because if we check the power rating we ought to have by multiplying the current going through it by the voltage, we'll have that what we require here is a 224 milliwatt resistor. Okay, so this is a 1/4 type resistor, which is the 250 milliwatt resistor. We're normally supposed to go 2 times the calculated wattage. So since we have 224 milliwatts as the calculated wattage, we ought to go up to 448 milliwatts minimum, okay, for our selected resistor.